Welcome to the fascinating world of salts, substances that play vital roles in chemistry, industry, and everyday life. From preserving food to powering batteries, salts are much more than just table salt. But how are they actually made? Salt preparation is a core concept in chemistry. Depending on the type of salt, its solubility, and the reactivity of the reactants, chemists choose the most suitable method. In the laboratory, the goal is to prepare salts that are pure and safe for analysis and experimentation. In industry, the aim is large scale production with maximum efficiency and minimum waste. Whether it's by neutralization, precipitation, metal reactions, or direct synthesis, understanding how salts are formed lays the foundation for deeper study in both academic and applied chemistry. Sometimes the simplest solutions are the most effective. That's exactly what neutralization offers. One of the most straightforward methods of preparing salts is neutralization, a reaction between an acid and a base producing salt and water. This method is ideal for soluble salts like sodium chloride and potassium nitrate. For example, when hydrochloric acid reacts with sodium hydroxide, it forms sodium chloride and water. To ensure a clean product, the reaction is done without excess of either reactant, reducing the need for purification. Want to see chemistry in action? Just drop a piece of metal into acid and watch the bubbles form. Reactive metals can form salts by reacting with acids, releasing hydrogen gas in the process. A common example is zinc reacting with dilute sulfuric acid to form zinc sulfate and hydrogen gas. This method works well for moderately reactive metals, those that can displace hydrogen but aren't too hazardous to handle. Fizzing and bubbling during a reaction? That's a classic sign of carbon dioxide and a salt being formed. Metal carbonates or hydrogen carbonates react with acids to produce salt, water, and carbon dioxide gas. For instance, calcium carbonate reacts with hydrochloric acid to form calcium chloride, water, and carbon dioxide. The visible effervescence provides an easy way to tell when the reaction is occurring and when it's complete. Sometimes, to make a salt, you need to make it fall, literally, out of solution. For insoluble salts, the precipitation method is the go-to approach. It involves mixing two soluble salts where one product is an insoluble salt that forms a precipitate. For example, when barium chloride reacts with sodium sulfate, it forms barium sulfate, a white precipitate, and sodium chloride. The precipitate is then filtered, washed, and dried to obtain the desired salt. What happens when two pure elements come together in perfect proportion? In some cases, they form a salt. Some salts can be prepared by the direct combination of elements. A classic example is sodium reacting with chlorine gas to form sodium chloride. Though simple in theory, this method needs strict safety control as both sodium and chlorine are highly reactive. On the industrial scale, salt preparation is all about efficiency, cost, and purity. Sodium chloride is commonly obtained by mining rock salt or evaporating seawater. The ammonia soda process is used to manufacture sodium carbonate in bulk. For salts of sulfuric acid, methods like the contact process and lead chamber process are used. These large-scale methods are essential for producing the salts needed in agriculture, chemical manufacturing, and everyday products. Let's wrap up with a quick summary of how salts are prepared. Salts can be made using a variety of methods depending on the type of salt and the reactivity of the reactants involved. These include neutralization, reaction with metals, reaction with carbonates or hydrogen carbonates, precipitation, and even direct combination of elements. For example, acid-base neutralization is used to make soluble salts like sodium chloride. Reactions with active metals or metal carbonates produce hydrogen or carbon dioxide alongside the salt. Precipitation reactions are especially useful for making insoluble salts like barium sulfate by combining two soluble reactants. And finally, industrial processes like rock salt mining, seawater evaporation, or the ammonia soda method are used for large scale salt production with a focus on cost, yield, and purity. Understanding these methods helps us not only in lab work but also in appreciating the scale of salt production in daily life and industry.